the stages of the modeling process so you have some idea of where things are situated when we talk about them later in the course. And then I want to talk about these couple key things which may be essential for your projects. In fact, I've even mentioned one of them in an email to one of you concerning model process. So if we ask about the model process as a whole, if we sort of visualize what's going on in modeling, it's an iterative progression among a set of stages. Okay? There's an order to it. There's something orderly to it. There's something that involves, it's a recorded video. There's something that's very regular to it. It proceeds in stages. So often early on, and we're going to be talking about this today, we have a problem conceptualization. What is it you're trying to capture, and what do you need to be thinking about to accurately capture this sort of process? So we're asking, what is it that we're get after here in the modeling? What questions are we trying to answer? What problem are we trying to solve? What's the nature of the issue that makes us feel that modeling is desirable? Is it we're trying to figure out some particular best placement of a resource, particular angling if we're designing a physical experiment? Is it instead that we want to understand the drivers for some data that's been very puzzling to us? So problem conceptualization is done early in modeling, and this is where the decisions about the scope of the model are made. What goes in that model and what doesn't? I talked with you last time about an analogy between models and something that should be very familiar to most people in the course. What was that thing? It's a map. And I argued that just as there's no perfect map, there's no perfect model. The idea here was that models are specific to general purposes, and the same thing is true with maps. So I argued that the type of map you'd use to plot your drive through Saskatoon will be different than if you were trying to plan your running map through Saskatoon, which you'd really want to focus on Mewasin Trail and certain trails. You want to plan some aspects of changing the topography so that flooding would be less of a problem. You'd use a different map that showed height and elevations, as well as some aspects of water flow, storm drainage channels, etc. Hydrology map, similar for an electrical map, etc. These are different sorts of abstractions, and models are abstractions. And we, particularly those who are from computer science background, will find that particularly with agent-based models, there's this huge temptation to put everything into the model. You can add things in very flexibly. Particularly with agent-based models, our ability to describe things at a mechanistic level, describe the general sort of processes, describe a theory at a mechanistic level, often outstrips the data that we have, the understanding, and most importantly, our needs. And so within the problem conceptualization phase, one of the most important steps you can take is to clearly scope the model. What are we, for right now, what does this model include and what it doesn't include? And you start simple, and then you add things in as there's a confidence is acquired that it's important. And you can do experiments that we'll talk about as to whether it's important. Okay? So problem conceptualization. Problem mapping will be sort of mapping out aspects of the system so we roughly understand how it works with types of diagrams so be understandable to people from whatever background. We call them boundary objects. These are common objects that I can look at, a sociologist could look at, someone who's a medical doctor could look at, someone who's a transportation policy expert could look at it, and they could all understand what this means. It's in simple enough language. There might be a few words of explanation needed, but it's something obvious. For those who have seen UML before, how many people in here have seen UML case diagrams? Case diagrams, sorry. Just kidding. Okay. So you show individuals as stick figures, and then you have them interacting with some system or what have you shown. So they go to a terminal and type something, and something pops out for Joe who's over here, what have you. So it's those sort of diagrams, so sort of rough sketches of what we're talking about. But it shows maybe what the major agent classes are. Maybe it shows something about the major variables in the model and how they relate to one another, what depends on what. But it's an extreme abstraction. Most importantly, It's qualitative. It doesn't allow us to simulate it. Okay? We can't simulate a use case. We can't run a use case diagram. There's no run button, right? It's not precise enough. It's not specific enough. And similarly, these sketches, they're not specific enough. Okay? We then go to modeling phase where we're getting very specific. We're articulating our operational theory captured in the model in very specific terms. Specific enough to run it. In other words, we have to specify a set of information. We have to specify equations. What depends on what in what way. When we change X, how exactly does Y change? Now that doesn't tell us overall system behavior. The model simulation is going to do that. But we have to tell how the pieces fit together. Or we have to tell the rules by which agents move, for example. Precise terms, in the terms that a computer can understand, right? So that's model formulation. And then we go through phases, model calibration, where we're acquiring confidence in the model by comparing it with various data. And we're often adjusting parameters that aren't well known to best accord with actually observed empirical data about the overall system behavior. So maybe we adjust some uncertainties in Saskatoon when we're simulating Saskatoon traffic about how quickly people accelerate after traffic light changes or what have you for different classes of vehicles. We adjust those so that we match overall data on how long traffic jams are at the top of, at several locations around the city. So we're adjusting certain parameters that we don't know so well to best accord data, often about the system as a whole. Okay. Model testing involves further checks on a model, and the placement of this vis-a-vis calibration is a little bit arbitrary. Model testing, ladies and gentlemen, involves several tests you can conduct in a model to sort of probe its reliability. And then we go through often, once we've acquired confidence in model, policy evaluation. We say, okay, what does this say for our decisions? What does this tell us about which decision is more desirable than which other, what else between them are, and knowledge translation, okay? Often at this stage, policy evaluation, you're having a wide variety of stakeholders interacting with the model very closely. If they haven't been earlier, they're interpreting model runs, seeing the output, and ideally interacting with it to ask questions on their own, although a lot of models don't directly allow it. Okay, and there's a later phase of knowledge translation. This is the broad modeling process, knowledge translation, putting those effects into use and changing how people think about it through interaction with the models. Now there's this framework, the overview and design and details framework, which was articulated by a set of modelers, particularly those from ecological modeling background. And there's a recommended book for this class by Railsbeck and Grimm, who are two of those who are behind the specification. Recently it's been updated with an ODD plus specification that's even more helpful, I think. We're not going to have time to go through this in detail. My lectures online do so, again, for those who are interested. But I will just note that in terms of the ODD, we're going to be talking about this first part today, and this falls into sort of the overview and high-level design. These later phases fall into sort of design and details associated with ODD. This is just one helpful way to think about it. Now, there's a couple key points, though, I want to get across to people, and I'm just going to